Lesson 9.4 is about ellipses. So let me teach you some vocab first. On this diagram, we're going to label the major axis. So on this ellipse, this long line segment, that's the major axis. And this is a horizontal ellipse. If you have a vertical ellipse, the major axis would be vertical. All right, next up we have the minor axis. I'll label this in blue. So the minor axis is the short one. So these are minor axes. All right, next we have the vertices. So the vertices are on the end of the major axis. The co-vertices are on the end of the minor axis. And the foci are already labeled on the first ellipse, but we have to label them on the second ellipse. So they would be somewhere around here. Okay, for number 1, we're going to graph this ellipse. There are no parentheses on the top, so this ellipse is centered at 0, 0. Okay, then look underneath x squared. You see an 81. The square root of 81 is 9. So what that means is, because it's under x, you want to go left and right 9 units from the center. Underneath y squared, we see a 3, or actually we see a 9. But if you take the square root of that, that would be 3. So because underneath y squared is 9, we go up and down the square root of 9. So we go up and down 3. And now we make an ellipse out of the 4 outside points. Right. We graphed it. They want us to find the length of the major axis and the length of the minor. So for the major axis, we went left 9 and right 9 from the center. So that makes a total of 18. The minor axis, we went up 3 and down 3, so that makes a total of 6. So it's kind of like completing the square, but in reverse order. Instead of dividing by 2 and squaring it, you kind of reverse that process. You square root and then multiply by 2. Same thing here. Square root was 3, then multiply by 2 makes 6. Alright. Now this one is going to be a vertical ellipse. I can tell because y has a bigger denominator. On number 1, x had a bigger denominator. So let's do this in reverse order. The major axis, you're going to take the square root, which is 7. Then you're going to double that to make 14. The minor axis, you take the square root of 25, which is 5, and then you double that to make 10. Alright, there are no parentheses in the numerator, so it's centered at 0, 0. The square root of 49 is 7, but that's underneath y, so we're going to go up 7 and down 7. Square root of 25 is 5, so we're going to go left and right 5. Okay, number 3 is not centered at the origin. So always start with x when you're doing coordinates. So we see x minus 4, so we take the opposite, positive 4, and positive 2 for the y. So that's our center, 4, 2. underneath y we see a 36. Square root is 6. So we go up 6 and down 6 from the center. Underneath the x we see a 16. Take the square root, which is 4. So we go to the right 4 and to the left 4. Then we make our ellipse out of the 4 outside points. Okay, the major axis, we went up and down 6, so that makes a total of 12. Minor axis, we went left and right 4, so that makes a total of 8. Looking at number 3, y had a bigger denominator, so that made it a vertical ellipse. Number 4, you can see x has a bigger denominator, so this one is going to be a horizontal ellipse. Alright. Doesn't matter what order you do these in. We could write the major and minor axis first and then graph it. So the square root is 7. Multiply that by 2, you get 14. Square root here is 5. Multiply that by 2 and you get 10. This is going to be centered at -4, -3 because of the parentheses on the top. So let's graph that point, -4, -3. And underneath x, we see a 49. The square root is 7, so we go left and right 7 because x means side to side. And underneath y, we see a 25, so we're going to go up and down 5. And then we make our ellipse. On the top of the second page, we have the standard form of the equation of an ellipse. So the way you could tell whether it's horizontal or vertical is by figuring out who has the bigger denominator between x and y. So whichever one has the bigger denominator, that tells you the orientation. And you need to know that a is always bigger than b. So if x has the bigger denominator, then it's horizontal. If y has the bigger denominator, then it's vertical. A is always bigger than b. Okay, looking at number 5, we can tell that's horizontal because it's longer, sideways. That is also centered at the origin. So we're going to use the horizontal formula. And I'm not going to use any parentheses because it's centered at 0, 0. So on top we would have x minus 0 squared and y minus 0 squared. We don't need to write minus 0. Alright, so from the origin, how far did it go left and right? It went left 3 and right 3. We square that length and we get 9. From the origin, how far did it go up and down? It went up 2 and down 2. We square that and we get 4. Okay, so to find the center when it's not graphed for you, you can take the midpoint. So you could either take the midpoint of the ends of the major axis, or you could take the midpoint of the ends of the minor axis, or you could even take the midpoint of the foci. So the midpoint, well, I could already tell there's going to be a 4 in the x. And then looking here, I can tell that both of these have a -3 in the y. So it has to be a -3 in the y. Alright, so the center is going to be 4, -3. and they give us the ends of the major and minor axis. So 4, 2 is up here. 4, -8 is off the graph right here. Now the minor axis, the endpoints are 1, -3, which is here, and 7, -3, which is here. So I'm graphing the ellipse even though we didn't have to. Alright, so looking at that, that looks a lot longer in the vertical direction. So I'm going to use this formula that starts with a y. And I know that the other side is always a 1. Alright, so using the center that we found, I want to do the opposite, and that's the y coordinate. And the x coordinate is 4, so I put -4 here. Alright, how far did we go in the major axis direction? From here to here, how far was that? That was 5 units in length. So underneath y, we take 5 and we square that. That's 25. Alright, how far did we go to the side? So from here to one of the sides, that looks like 3 units. So underneath the x, since we went 3 units to the side, we square that, we put a 9. Alright, the vertices, I'm going to plot those for number 7. The vertices are -7, 2 and 5, 2, which doesn't fit on the graph unless I count by 2's. Alright, so the vertices, -7, +2, and 5, 2. Alright, because those are side by side and those are vertices, I know vertices are on the major axis. So this is going to be a horizontal ellipse. So I can already start to write it out using the horizontal formula. Alright, the co-vertices, -1, 0, and -1, 4. Alright, so with those 4 points, it's pretty obvious what the center is going to be. I see the number 2 twice in the y. I see the number -1 twice in the x. So the center should be -1, comma 2. And looking at our picture, looks like that's in the middle of both of those sets of points. I'll graph the ellipse even though they don't ask us to. Alright, so x was -1, we do the opposite, x plus 1. The y was 2, we do the opposite, y minus 2. Alright, how far did we go to the side? So from here, how far was that? Looks like 1, 2, 3, 4, 5, 6. So we went 6 to the left and 6 to the right. Square that, gives you 36. How far up and down? Well, my graph counts by 2's. So we went up 2 and down 2. We square that to get 4. And that's our equation. Okay, so again, you can get the center just by looking at what coordinates repeat. So anytime a coordinate repeats, it's going to go in the center. So the x is 3 for both points of the vertices. The y is -6 for both y's in the co-vertices. So there's our center. Let's try to do this one without graphing it. So the vertices are always the major axis. Look at these points on the major axis. Are those points side by side, or are they on top of each other? So if you need to graph it to figure it out, you can, but those points are on top of each other. So that makes this a vertical ellipse. Alright, so we know it's going to be a vertical ellipse. We know the y-coordinate is -6, so I put a +6 here. The x-coordinate of the center is +3, so I do the opposite, -3. Alright, from this center here, how far up and down did we go? So how far is that center from those vertices? The answer is 8. So if you go from -6 to +2, that is 8. If you go from -6 to -14, that's also 8. So under here, we're going to put a 64, 8 squared. Alright, from this center, how far is it to either of these points? So notice, the -6 is not changing. So we're just going to figure out how far are the x's from each other. So from 3 to 7, that is 4. From 3 to -1 is also 4. So 4 squared is 16. Alright. If you need to see the graph, I'll do that now. So we need to count by 2's for everything to fit. Let me label that first. Okay, so we were given the vertices are 3, 2 and 3, -14. We're given the co-vertices were -1, -6, and 7, -6. Alright, so using that picture, we could tell where the center is kind of by forming a cross. The center has to be in the middle of both of those. So the center has to be here, which we already figured out was 3, -6. The ellipse is here. Looking at that picture, that ellipse is a lot longer up and down, so it's a vertical ellipse. Okay, that is all for the first half of 9.4.